Right, so we've got to find the ratio of AP to PM. So we're trying to find the ratio of this length here, AP, whoops, to this length here, PM. Now, we're going to do this. Now it tells us a vector for the line for AP. It gives that in vector form. Now, because APM is a straight line, if we can find a vector equation for PM, right, because they're on this is one continuous line, then the ratio of AP to PM is going to be the same as the ratio of the vector AP, the magnitude of that, to the magnitude of the vector PM. Okay, now when we're talking about ratios, really we're talking about just numbers. We're not. You can't really take the ratio of two vectors because obviously the vector contains a direction as well. However, in this case, because AP and PM are on the same line, we can effectively take the ratios of the magnitudes of those two vectors. Now the way to do it, now it also tells us that M is the midpoint of BC, so I'll just stick my lines there showing that those two are equal. And I think the first thing we need to do is to work out an expression for this vector CB. And that's quite easy because if we think about the triangle here, you can see that AB is the same as going from A to C, AC, plus, and then going up from C to B. Okay, simple vector addition. Now, however, we also know that AB is 4A, and we know that AC is 2B, which means we can get an expression for CB, and CB, the vector from C to B, is just going to be equal to 4A minus 2B. Okay, and if we want to go halfway up from C to M, that vector is just going to be half of the vector CB, which is going to be 2A minus B. Okay. Now, what I'm going to now try and do is I need to try and work out, we know what the vector AP is, I need to try and find the vector PM. Now the vector PM is going to equal the vector from A to M minus the vector from A to P. So PM is AM minus AP. Okay, and we know what AP is, it tells us. So we now need to try and find the vector from A to M. And there's two ways we can do this. We can either go from A to B and then down from B to M, or we can go from A to C and up from C to M. So I'm going to do it, I think, from going along AC and then going up from C to M. So the vector AM equals the vector from A to C and then plus that vector going up from C to M. Okay. Now, from A to C is just 2B, and from C to M we've just worked out is 2A minus B. So if we collect like vectors here, we're going to have 2B minus B is just 1B, and then plus 2A. Okay, now what we can do now is we can say, right, using this equation here, we can say, right, that means the vector Pm is equal to B plus 2A minus, and then we want the vector AP, which we're given, minus 3 over 2A plus 3/4 B. And we can then collect like terms here, and we're going to have B minus 3/4 of B, which is 1/4 B, and we're going to have 2A minus 1.5 A, which is going to give us 1/2 A. So we've now got a vector for Pm, and we're given the vector for AP. So the ratio which we need is going to be the modulus of AP, which is 3/4 A plus 3/4 B, modulus or magnitude, the size of the vector, the length of the vector, 2, and then that one, the other one is a 1/2 A plus 1/4 B, magnitude of. Right, now what we can do now is we can, if we take 3 out of this one, we're going to have 3 lots of whatever this magnitude is, 2, and then it's just going to be 1 lot of that, 1/2, I'll put a 1 there, 1/2 A plus 1/4 B. And we don't need to know what these magnitudes are now, because you can see that we've just got 3 times something to 1 times that thing. So the final answer is just 3 to 1. So the magnitude, or the ratio AP to PM equals 3 to 1.